So what I'll be presenting to you forms part of my results for my MSc study on the species of Berberis. Okay, so it's no need for me to explain any invasive terms to you. We all know, or the majority of you know already, that they are one of the biggest threats to biodiversity and that they cause considerable economic losses. So the cost of eradication, seeing that it exponentially increases with population size, the early detection and eradication is needed and is definitely the most cost effective. Now all species follow a general trend, all invasive species at least, whereby when they're introduced they have a low population size and then they are in what we call the lag phase, where after they reach a phase of rapid exponential increase and eventually they increase in population growth as they reach the geographical bounds of their new habitat. Now it's in this lag phase that we really have a window of opportunity to cost effectively eradicate these species, and it's exactly here that we must act. So for my research questions in this study, first of all, I want to see which species have started to naturalize in SA, if any, and what the extent and characteristics of these populations. And then also what the seed viability is, how suitable is our climate to these species, and eventually, do these species have the potential to become invasive in South Africa? So a little bit about history and records. In SAPA there are only 4 documented records of Berberis, one of them with no coordinates whatsoever. So from the beginning, very data deficient. Data deficiency was a big problem. Also the herbarium records, there are only 34 documented, all of which are of cultivated origin. So to get to that, Berberis julianae, the third species, all Berberis species are characterized by these 3 branch forms that you can see in number C. Now they also have these characteristic yellow flowers, and in this species, Berberis julianae, you can see in number E that they have clustered inflorescence and these characteristic purplish berries. Now Berberis julianae itself is native to the eastern parts of China. The second species is Berberis aristata. Again you can see the 3 branch spines there in number D, so similar characteristic. And also yellow flowers as indicated by A. But the difference here is that Berberis aristata is a much larger shrub than Berberis julianae. And also you can see by number F, the inflorescence, they have a raceme-like inflorescence as opposed to clustered inflorescence as Berberis julianae has. And Berberis aristata in turn is native to Nepal in the region of the Himalayan mountains. So for my materials and methods, I conducted surveys which I got the localities from SAPIA and from SANBI. I did a survey technique which extended beyond 50 meters of the most isolated plant, and I GPS every specimen. Population structure and reproductive size. This I only did for Berberis aristata as of yet, because I initially only surveyed Berberis julianae by GPSing them. So I'm waiting for the flower season this year, and I'm going to do exactly the same for that. Now, I made various measurements, and I used the generalized linear model in R to get an estimate of the reproductive size of the population. As you'll see, I used a subsample of that population because it was much too large to include the entire population. I had no idea that it was so big. So I chose a homogeneous representative subsample of the population to get the bigger picture. Then I conducted seed viability. Now this I only did for Berberis julianae as of yet, and the reason was I only last month got the seeds of Berberis aristata, so that is currently in progress. Only be reporting on Berberis julianae. Now, to note, there was no scarification or pre-treatment whatsoever, and I incubated them in an alternating temperature scheme which is recommended for Berberis seeds. Then I did bioclimatic modeling for both of them. Occurrence data I got from various sources. I removed false localities and duplicate records. And the environmental data consisted of 2.5-minute Esri grids, and I only used climatic data in the modeling, which I obtained from the Walton data portal, and I used 19 biovariables, and only the significant ones were used in the final models of the species. The modeling itself was conducted in Maxent, and I used a cross-validate algorithm, so I could make better use of a bit smaller data sets. And then finally I followed the Australian weed risk assessment protocol to get an idea of the risk of what the species pose. So it's a series of questions which you research and answer, and then based on the scores that you give, or the answers you give rather, score is allocated, and depending on the total score, species either rejected or accepted or re-evaluated. Now, since this was